Bum, 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 bum. Hello. Hey, we got Barrick here too. Hello, guys. Okay, I'm almost ready. I ended up at work this morning, so I didn't quite finish my PowerPoint that I wanted to use today. So I've got one more slide I gotta put in. Hey, Gary's here. Hello, everyone. So I just gotta put in one more slide. Dun, 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 dun. Bum, 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 bum. I need to add a text box here. There we go. Okay. Would one of you guys quickly give me an example of a binomial Latin name? I just want to throw an example down and I can't think of anything off the top of my head. Well, I guess that's not true. I do have one. I always seem to remember the full Latin name for sunflowers, so I'll use that one. Okay. I guess that's what the lesson's for. Never mind. Okay. I need to make this bigger. Boop, 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 boop. Increase size. Here we go. Nope, that didn't work. I need to insert a shape. This shape will do. I'm gonna make that shape bigger. This? Yeah, wait. Okay. I'll do another little text box here. Okay. Let's see if I can quickly steal something from the internet about this dude. Let's take that image. Here we go. we're gonna steal this image. We're just gonna use this one, because what are you gonna do? Turn me in for plagiarism? Ha 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 ha. Okay, I think we're good. I think that's everything. All right, I am good. Bum bum ba bum. Done. And I just need to add it to Google Drive so that I can have it on the other computer, because I made it on my laptop and I need it on the PC. Okay, let me open it up. Thanks guys for bearing with me for this. Oh, I made that too big. Okay, Gary, I see you. Where are we here? Streamer arrested live on stream. No! Oh, also, I was hella hungover this morning. Woo! That was fun. I went to work and I weeded for 4 hours or 3 hours or however long that was, 3.5 hours. Yeah, felt great. So good. It's past now. I feel much better now, but like seriously, lol. Okay, we're gonna use this scene, I think, even though this is my arts and farts scene, it'll work. What do I want? I need to add screen capture. Is it display capture or browser? I think it's browser. No, I think it's display capture. Plus browser? No, fuck. What am I? Fuck. Window capture. That's what I'm looking for. I think that's good. Properties. How am I gonna do this? Hey, Fruit Salad Puncher! I'm just trying to figure out how I want to do this slideshow so you can see it properly. Maybe I can view slideshow? Oh, it just made it huge. That didn't work for me. What if I... How else can I do this? I want this to go away. Ah, that's better. Okay, what if I... Yeah, we're just gonna go like this. This works. That's fine. Don't worry about it, guys. This is more than good enough. I think I might need to move this bead. Nah, this is good. All is well. Alright guys, you guys ready? We're gonna do some learning. I hope you're ready. I'm gonna take a sip of my drink that's not alcoholic this time. Okay, let's get to it. Alright guys, welcome to NEP Teaches a Class on Scientific Classification! Yay! You guys are allowed to ask as many questions as you like during this, by the way, so like, please ask questions. Let me know if there's something you wanna know more about. This is a pretty basic overview of what classification is and how it works, and this is hopefully so that you guys can better understand what the fuck I'm talking about when I start going into when I start talking about different insects and plants and their relations, the degree of relation. This will come in handy. So if you want to learn more about plants from me, plants and bugs, you're going to want to have a grasp of this concept, classification. Okay, so we'll get started. So yeah, what the fuck is that? Scientific classification. Oh, no, that's not what I wanted. I want to go to the next slide. No, how am I gonna... There we go. So, some basic terminology for you guys. And turn this music down just a teeny bit because we don't need it too loud. So, terminology for today. The things hopefully you'll kind of have an understanding of when it comes to classification. Taxonomy, nomenclature, cladistics, and phylogeny. So technically, I'm not going to go super deep into any of these in particular. We're just going to kind of grace the surface of the topic and you guys can learn about it. But yeah, so taxonomy is the branch of science that is concerned with classification. So anytime we're talking about classifying organisms, we're talking about taxonomy. It's a system. Nomenclature is how we determine the names for things. So, for example, a scientific name, as humans, we are Homo sapiens, right? So that's our classification. That's our species name. And that's where we're at. Cladistics, or clades, is an approach to this kind of work. So clades don't really necessarily take like the genetic linkage of things into consideration. Clades is more like talking about features, and yeah, we'll get to clades again. But yeah, it's an approach to biological classification in which organisms are categorized into groups based on most recent common ancestry. So I'll show you an image of that. We'll get to it. You'll see it. You'll know what I mean. Yeah, and then phylogeny is the evolutionary development and diversification of a species or group, or a particular feature of an organism. So we'll get to that too, because phylogeny and cladistics are really closely linked together. You can't really have one without working in the other. Same with taxonomy and nomenclature. Those two are kind of like paired terms. Yeah. So do you guys have any questions about these terms, or shall I just keep going? I'm gonna just keep going. If you have questions, let me know. Throw them in the comments. I'll read them. All right. So the first thing that I thought we should start with is talking about binomial naming. And so these are the names, the scientific names that things have. So example, this is the scientific name for a sunflower. Helianthus anus is the Latin or the scientific name for sunflowers. And all of these names were first introduced as a way of naming things by this old dude. So this old Swedish man, not anus, anus is different. So this dude, Swedish botanist Carl Linnaeus. If you took high school biology, you've probably come across this man before because he's considered one of the fathers of modern day biology. He wrote a book called the Systema Naturae, and what he did is he classified and named species. So he kind of existed around the same time as Darwin. So as Darwin was exploring and finding things in the air quotations new world, you know, that world that people already lived in, he made it make sense. And so part of the reason for this is because we have different names for the same things all over the world. So what I might call Gary and I were talking about this earlier. I was bothering him while I was at work about plants and things. And so we were talking about creeping Charlie. Creeping Charlie is a weed. It grows where I live. It grows in Europe. It grows all over the place. So creeping Charlie goes by a different name in France. Wow, shocker. Who would have thought? So if I'm talking about creeping Charlie and Gary's talking about creeping Charlie with a different name, how are we going to know we're dealing with the same plant? You use the Latin name. And we use Latin because it's a really descriptive language that no one really speaks anymore, so it just sounds cool. But yeah, so Carl Linnaeus, he's kind of the father of taxonomy. Yeah, that one. Lier. I don't speak a French. But father of taxonomy. So, so he kind of invented the binomial system. It's called binomial because bi means two, nom means name, binomial, get it? Two names. It's a two-name system. Everything has two names. We are Homo sapiens. The sunflower is Helianthus anus. When you write these names, if you are handwriting, you have to underline the name, and that's how you acknowledge that it's a Latin name. But if you've typed it up and you have the ability to use, italics, you should italicize the words. So I've italicized them because that's the correct way of doing it on a computer. But yes, if you're handwriting it, you just underline it to acknowledge that it's a Latin name. So binomial names are always set up the same way. The first is the genus name, and the second is the species name. If you have a variety within the species, so for example, say... here's a good one. So broccoli and cauliflower are the same vegetable. Same species of plant. One of which forms flowers, the other of which does not form complete flowers. You can take a guess as to which one's which. But more or less, cauliflower is a big aborted broccoli. Anyways, they consistently grow differently, right? They're different. They're the same plant, same species, but they have a vastly different feature, right? One grows broccoli, one grows cauliflower, and so you'd use a variety name. So I haven't really indicated it here on this, but let's see. I can add one in here. So for example, so I think that's the term, Brassica oleracea. Let me super, you can see. Give me a sec. I'm just gonna double check that I've got the right, yeah. Pretty sure it's Brassica oleracea. Yep, it is. Okay. Okay, I've got it. You're welcome! As you can see, I was looking up Handmaid's Tale swimsuits and stuff for this lesson. Okay, but yeah, so basically, So even though broccoli and cauliflower are the same species, so the top one here of these two, let me make that bigger. All right, so what we have here is these are the names for broccoli and cauliflower. Brassica oleracea variety italica is broccoli. Brassica oleracea variety botrytis is cauliflower. So it's the same species. They have the same genus name, they have the same species name, but then we indicate that they are different by using the variety. Sometimes things will be classified as a subspecies, meaning it's almost its own species, but it's still part of the same thing. And the way that we determine if something is the same species or another, they have to be able to reproduce and create viable offspring. So that's the term, viable offspring, meaning they can procreate together, but the offspring also has to be able to procreate. An example where things can procreate together, but you have a unviable offspring is mules. So horses and donkeys are each their own species, right? They're different animals, but they can mate. They can breed together and you get something called a mule. However, all mules are sterile. They can't produce babies. Like, they can't produce babies because that's what happens when you have a mule. They can't. A mule and a mule can't have a baby mule together. They're kind of like a subspecies, I guess. They're not their own thing. They're not a different species. But yeah, so anyways. Does this make sense? Have I made things make sense as far as what these names mean? When you see one of these names, it's a species name. Yes, Helianthus indicates the genus, and Anus indicates the species, but together, Helianthus anus is how you get the species name. The other thing I wanted to note is if you want to, the rules behind naming. So italicized, always capitalize the first letter of the genus name. You never capitalize the species name, only the genus name. So these I should make italic because that's what they are. Yeah. And if you want to shorten it and you want to say, there. So because I've indicated that this is the full name, I can shorten brassica just to B because that's never going to change. So I would never shorten this second word. You never shorten the genus or the species name, but you can shorten and abbreviate the genus name with just the first letter. You still have to keep it capitalized, but that's how that works. Oh my god. Can you guys like just throw some emojis or something in chat so that I know that this is like, give me a thumbs up. If this is making sense, give me a thumbs up. If it's not making sense, I don't know, spam something else. We're gonna continue on. All right, a salute it is. Perfect. And some thumbs. Yay. All right. Moving on. Taxonomic ranks. So we mentioned genus and species. So example here, we have the fox. Red fox is Vulpes vulpes. That's its Latin name. As you can see, it's italicized. The first letter is capitalized. That's its species name. Now, if you go backwards in the classification tree, we have the species, we have the genus, and then we have family. Above that, we have order. Above that, we have class. Above that is the phylum, kingdom, domain. So I'll break these down. We'll talk about each one so you kind of have an idea of how they work. So the domain is the most broad category. We are all eukaryotes. Eukarya, and I think there's 4 domains, 3 or 4 domains total. This domain indicates that your cell has a nucleus. That's quite literally it. It's a nucleus in a cell. That's how you get it. That's the category here. Kingdom is another really, really broad category. So for the fox, kingdom is Animalia. So it's an animal. Kingdoms here differentiate into things like plants, fungus, animals, bacteria. No, bacteria aren't even in eukarya. They're in the prokarya. They're prokaryotes. But yeah, so kingdom is broken down into these other general categories. A little more specific, but not too specific. Following kingdom, we have phylum. It's another level of classification. We're getting a little bit more specific. This time, it's phylum Chordata. Phylum Chordata indicates that it has a spine. That's all that is. Chordates have spines. So here, under kingdom Animalia, we lose, as we move into the phylum level, we lose all of those things that are spineless. So if it doesn't have a spine, it's not Chordata. Then, underneath that, we have class. In this case, our class is Mammalia, because it's a mammal. Mammals are milk-producing, they lay, live birth, so not an egg, and produces milk. That's what makes things mammals. Marsupials, so kangaroos, echidnas, all of those guys from Australia, they branch off here. Marsupials and mammals separate at this level. Following that, we have the order, and that is Carnivora. So this is a carnivorous animal, right? It's a meat eater. Carnivora is typically indicated, I believe, through teeth. I think that's how people determine if it's carnivora or not. Family, again, another specification. Now we're in the Canidae family. This is all the canids. So all canines are in this. So foxes are technically out of the canine group. One more level of classification in, we have the genus, and this is Vulpes. Again, that's our genus name. You see it appear the second time in the species name, Vulpes vulpes. So this is taxonomy. This is the ranking of all of this. And they always go in this order. And that's how you get to someone's classification. That's the whole list. So Eukarya, Animalia, Chordata, Mammalia, Carnivora, Canidae, Vulpes, Vulpes, Vulpes. That's his official title. But we don't need all of that information because we have the species name. The species name indicates this long list of connection to other things. How does that make sense? So binomial naming comes out of this classification into kingdoms, classes, orders, genera, species, blah, 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 blah. That's how it looks. Thumbs up, thumbs down? How we doing? How is everyone? Does this make sense? I have to admit, this is, yeah, I mean, they're technically in there, but, like, it branches out because they're not mammals in the sense that, like, the common term mammal, they do branch out from there. Anyways, I see that Varric understands. I don't know. I feel like Kaylee's the one that needs to indicate whether or not this makes any sense. Okay, we're gonna continue on. So a pro tip, if you wanna learn this order and keep it in your head, you can use, is it an anagram? Fuck, I can't remember if it's an anagram or something else. But yeah, you can use these goofy, like, word play on words to remember which one's which. So this is the one you don't expect to understand. This is the one that I learned in school, so it's the one that I'm giving you here, but there's so many versions of this for kingdom, phylum, class, order, genus, species. Oh, I forgot to put family in here. That's what the F is for. Right. Kingdom, phylum, class, order, genus, species. Bum bum bum. Yeah, King Philip came over for good soup. You use all the same first letters. It's a saying rather than this list. It might make it easier to remember. But yeah, if you want to, you can use that. You can find another one online. There's so many of these that exist. Okay. Okay, so going from taxonomy, which is kind of the more rigorous approach, taxonomy is the official classification of things. Clades and cladistics is more of a general method. Like, it's more broad. It's way more broad. Yeah, you can use whatever the fuck you want, Varric. I don't care. It could be king potato for all I care. Yeah, so this is an example of a clade. So this is a cladogram is the term, cladogram. And it's usually used to distinguish characteristics of things. So for example here, our common ancestor that we're comparing to is a tortoise. And each time we move up the clades, up the cladogram, we distinguish another feature. So the tortoise is here because it doesn't have hair. Everything beyond this point in the cladogram is going to have hair. The next thing, we have a horse, and our next feature is carnivorous, right? Okay, so continuing up, everything up here is going to be hairy and carnivorous. So then we get the wolf, and then going there we have retractable claws. So there's our wolf. He doesn't get to go any further up the cladogram. Retractable claws becomes the next piece. You have the leopard and a house cat that have retractable claws. And then the last defining characteristic is going to be that purring. A leopard's not going to purr, or I don't know, maybe they do purr. Either way, I just found this on the internet. Because I don't feel like making all of these diagrams. Too much work. Anyways, this is a cladogram. This is how cladistics works. Each of these little branches is a clade. A clade is just a grouping. You can be really specific. You can do a cladogram for like features, like really, really specific features in like a very specific branch of organisms. So say you want to just talk about snails, you could do that. You could do ones that have snail shells that twist in this direction or have a point or are rounded or whatever, and you can make a cladogram describing all those features and the degree of relation. So I've mentioned degree of relation I think twice now, but the degree of relation that I'm just trying to explain is that, like, house cat to leopard, the degree of relation is smaller than house cat to tortoise. That degree of relation is so much wider. There's so much more that has happened in between where they branched off from the from this, like, yeah, anyways. They branched very, very far back, and they do not share characteristics. So tortoise and house cat, quite different. Leopard and house cat, much more similar. Way closer in relation. Still, totally different species. Not that closely related in the grand scheme of things. But, you know, the degree of relation is much smaller. Alright. So I wanted to talk about how you use cladograms with phylogeny. So I mentioned this earlier right at the beginning when we were going over some of those terms. So taxonomy and nomenclature, kind of hand in hand. When you classify things, you need a name for them, and you use this classification system. Clades and cladograms are more feature-based. So this phylogeny shows the degrees of relationships between plants. So the reason I wanted to talk about seeds is seeds are not actually a common feature of all plants. They're a really specific group of plants called angiosperms. And yeah, flowering plants. Flowering plants produce seeds. Non-flowering plants don't produce seeds. That's how it works. But yeah, so our common ancestor here is green algae. And that's where that branches off. So this distance shows like a degree of relationship through time is kind of what that's saying. Anyways, continuing on. So algae doesn't really protect its embryos. It doesn't really create embryos, to be entirely honest. It just throws them out there. So these are the charophytes. I can't remember exactly which ones these are, but they produce kind of like almost spores, not quite spores, because spores have a hard coating, protective coating on the outside. Anyways, yeah. So they're our furthest common ancestor back here. The feature that we're going to talk now is embryo protection. So at some point in history, a branch of these things broke off and started creating embryo protection. So their babies were protected a little bit. And you get liverworts. You get apical growth, meaning growth from the top, or growth from, what do you call it? It stems from the same Latin word that apex comes from, as in like top, point. Yeah, so now we get mosses and hornworts. So they still don't produce seeds, but they do this and they do this, unlike the green algae. Now we get vascular tissue. Vascular tissue is the movement of oxygen and stuff through the system. So our vascular system is our blood system, our circulatory system. The vascular system in plants is like the xylem and phloem. It's what moves water up the plant and sugars and stuff down the plant towards the roots. And that's what this is referring to, vascular tissues. So now these have branched off and created a group that has vascular tissues, and we get club mosses. It's just a different type of moss. Then we get the megaphiles, which means the plants are fucking big. You're no longer dealing with such small little things like moss, like liverworts, which are quite tiny. You get big organisms, like ferns. Ferns still don't produce seeds. Ferns propagate by spores. So similar to fungus, they produce spores and they send them off, and there you go. You get a mixture of spores and you get ferns. And they have a really weird life cycle. Ferns are kind of cool. But yeah, so ferns branch off. Then we get the production of seeds. And we get the gymnosperms and the angiosperms. Now, the difference here is that gymnosperms are things like evergreens. There are cedars, junipers, pines, spruce, firs. Yeah, so that's a gymnosperm. They're the, how do I describe? Cones. They grow cones. So they don't produce flowers, they produce cones. Are you saying ferd? Ferd is a gymnosperm. Anyways. Yeah. Following that, we get flowering plants. Things with flowers, double fertilization, an endosperm, fruit. Double fertilization means you need a parent from the, I guess, plants don't really have a mom and a dad, but they do produce half, like humans and stuff. They produce, like they'll have a mother and a father, I guess. They'll have two donations of genetic information to get an offspring. So that's what that's referring to, double fertilization. It takes two to tango. Endosperm is the, it's part of the seed itself. It's the part of the seed that's full of nutrition, so that as the seed grows, it doesn't need to feed off of anything else right away. It can sustain itself for the first little bit of life. And then fruit. Fruit is something that comes from angiosperm seed production. The fruit, the fruiting body, is the thing that helps grow the seeds and protect the seeds. So this is a cladogram depicting the phylogeny of seeds. How is that? Did that make any sense? Have I described what's going on in this diagram well enough for you guys? Okay, continuing on. Okay, so we've kind of gone through all of the information now. This is everything I wanted to teach you. So phylogeny, clades, nomenclature, taxonomy, we've covered it. So this is why I wanted to have this talk with you guys. The degrees of relations among bugs and shit. So this is a really cool diagram. This is only part of a diagram, I should say. I wonder if you guys can see the whole thing if I make it really big. I think so. Yeah, okay. So, this is the branching and relations of all of the orders of insects. So we talked about orders. Orders are here. It's this level of classification. When we talk about insects, insects basically, they're their own class. Insecta is a class. Okay? So that's what this is. We are in the insecta, or almost the insecta. We have a distinction right here. This is where we get a big branch. We have the entognatha and we have the ectognatha. The entognatha, and I'm trying to remember why the differentiation, they're hexapods. They have 6 legs. Hexapoda refers to 6 legs. Hex meaning 6. Pod meaning feet. Six-footed. It's like why a foot doctors call a podiatrist. Latin comes up everywhere, guys. Learn your fucking Latin. It's useful. But yeah, so we get things like collembola, protura, diplura, things like silverfish, tardigrades. You get these really kind of prehistoric, very, very simple life forms. And then following this way, we get more of a... Oh! I think I remember what it is. These things just keep growing. They look the same from baby up until adulthood. They don't go through a metamorphosis of any kind. That's what it is. These guys go through some form of metamorphosis at some point. Some sort of bodily change. We have... the Archaeonatha are really similar, but not quite the same as these things. They're just a little bit more advanced. Anyways, breaking off from there, we have all of these other branches and degrees of relation. The further up the branching you have to go to get to the next, like, where it connects to the other thing, that's how far back it is in relation to each other. But yeah, so we have groups. So these are the groups I want to go through with you guys, so you guys can see, like, the degrees of separation between different insects. We have the Odonata. Odonata are dragonflies and damselflies. They're their own group. They're a really fucking prehistoric group, too. They've been around for a long time. And then, next to them, closely related, are the Ephemeroptera. Ephemeroptera are mayflies, or fish flies. A lot of people call them fish flies. Yeah, so then we have, Ephemeroptera. The next degree of relation is where we get almost all of this other stuff. The reason Odonata and Ephemeroptera are a little bit different is based on their wings and how their wings are attached to their body and how they function. Dragonflies have a different musculature system to all of these other insects and how their wings are attached to their bodies. Dragonflies can individually move each wing and they can kind of rotate and all sorts of stuff, whereas all of these are paired wings and they don't move independent of each other. But yeah, Ephemeroptera. Then we have Orthoptera, which are our locusts, our grasshoppers, our crickets. Orthoptera refers to their legs. Ortho, legs. Ha ha ha. Orthoptera. I believe that's what it was. Ortho had to do with their legs. We have Phasmatodea. Phasmatodea are the stick bugs. We have Plecoptera. Plecoptera are stoneflies. We have Dermatera. These are, I believe, fleas, because derma means skin. No, earwigs. That's what they are. They're the earwigs. The Dermatera are the earwigs. Terra, the okay, that's what it was. Yeah, so Orthoptera are in relation. I know the naming has to do with their legs though. So it refers to that back leg business. But yeah, so earwigs. Then we have Mantidea, which is the mantids. We have Blatidea, which is cockroaches. We have Isoptera, which is termites. I find this fascinating because Isoptera, Isotera, or however you want to pronounce them, they're way up here in this classification chart. This is where they are in relation to other insects. They're way more closely related to grasshoppers, earwigs, roaches, mantids, all of them, than they are to bees and ants and wasps, which are the other social insects. So I find that really fascinating that you have a whole social insect order up here, and it's evolved separately from how it's evolved in the bees and wasps and things and ants. Following that, we have the Pseucoptera, and I'm trying to remember what Pseucoptera are. I don't remember. I don't remember what the Pseucoptera are. There's something small. Then we have the Thysanotera, which are another small group of insects, and then we have the Hemiptera. So the Hemiptera. Hemiptera are the true bugs. So this is really fun. So when we're talking about insects, we talk about all of these. But when we talk about bugs, we're talking about these ones. Specifically right here. These are bugs. Right there. All of these are insects. These are bugs. Does that make sense? Yeah. I know, people think bug and insect is an interchangeable term. Not scientifically. When you actually get into like where the names and stuff come from, bug only refers to this group. Like we have grasshoppers, like we have dragonflies, we have bugs. In the bug category, there's so many. There's a huge diversity of Hemiptera. But the Hemiptera are distinguished through their half-membranous wings. So they have a set of fully membranous wings and they have a set of half-membranous wings. So they're called the Hemiptera, half-wing. Yeah, following from there, we have this next group, right? We have another branch of groups coming out. And here's where we have the insects that we are most familiar with for the most part. We have Hymenoptera. Those are our bees, ants, and wasps. They're also our sawflies and horntails. They come out of this group. We have Coleoptera, which are our beetles. We have Neuroptera, which are Neuropterans are hard to explain. It's things like antlions and owlflies. And I don't think you guys are familiar with what those are. A lot of people just assume they're flies because they have wings and they're small, but they're their own group, the Neuropterans. We have the Megaloptera, which are things like the snake flies, which aren't actually flies at all. Yeah, and then the Rhapidoptera, which I can't remember exactly which one's which. Yeah, anyways. Trichoptera are really fun. So Trichoptera here are caddisflies. And they physically, like on a physical level, they look really, really similar to these Ephemeroptera, which are the mayflies. But Trichoptera and Ephemeroptera, even though they look really similar, are not closely related at all. They've got quite a spread in their genetic history, their phylogeny. Yeah. After that, we have Lepidoptera, which are all of our butterflies, moths, and skippers. Just so you guys know, all butterflies are moths, but not all moths are butterflies. So there's no real major distinction between moths and butterflies, aside from a little bit of like behavior. they're all kind of falling under the category of moths. And then there's like a specific group of them that end up being the butterflies. And butterflies are typically just, they're awake in the day. Moths are more nocturnal, and butterflies are diurnal. They're awake in the daytime. Following those groupings, we have the Diptera, which are the flies, the real flies. Flies are two-winged. At some point in their history, they lost their second set of wings, and so they only have one pair of wings. So they have two wings, whereas all of these other guys have four. We also have the Siphonotera, which are the fleas. And we have the Mecoptera, which I can't remember exactly which ones those are. But anyways, that's like the degrees of separations within the insects and how things are related to each other. I hope you guys find that interesting. I think it's fascinating. This is one of those things that when I took entomology in school, the day we covered this like diagram business, I was so excited. It was so interesting to see how all of these things are related. Yeah. And then this is kind of cool too. Even though we have all of these different groups and they've all branched off and they all do slightly different things and whatever, when you look at the number of species, so let's say we have 100% of species of insects, 45% of those species are going to be beetles. That's just what happens. There are so many beetles. Beetles are the biggest group of insects. Lepidoptera is going to be in second. We have a lot of species of Lepidoptera. Same with Hymenoptera, bees, ants, and wasps. There's a huge amount of diversity in that group. Hemiptera are the true bugs again. They've got a pretty substantial set of diversity within their group. And then Diptera comes fifth with like almost 10% of insect species are flies. And then you can see it drops off quite a bit. There's not as many insect species in these other categories. Beetles are by far the most prolific. And that's not to say that there are more beetles on the planet. It just means that there are more beetle species. There are more individual species of beetles than there are individual species of Blattidia, which are the cockroaches again, you know? Yeah. And that's the end of my presentation. We have reached the end. I'm gonna go back to this here so you guys can still see your terminology. Any questions? You're welcome! Thanks so much for joining me. I'm not gonna stick around on stream for any longer today. I really just wanted to do this little bit. I know I usually stay on stream a little longer on the weekends, but because I'm coming back and I'm doing, oh, for anyone who's interested, tomorrow afternoon we have another event planned. It won't be on Twitch, it'll be on Discord, but you can get a tour of my garden. So if you want a tour of Nep's very own garden, join us in the Discord. We'll be there tomorrow, a little bit earlier than today, because I don't work tomorrow. But yeah. Anyways, I'm glad everyone enjoyed this. This was a lot of fun. I love teaching people these things. I always want to share all of this cool stuff. I find it fascinating. I get excited about it. I hope other people get excited about it. Yeah. Classification. Okay. Well, I'm gonna wrap it up. I don't seem to have questions from the audience. That's probably a good thing. Yeah. See you guys tomorrow then. In the afternoon for the garden tour, and then in the evening on Twitch for horoscopes. All right. Bye, guys.